Hi, welcome to a new video dedicated to the new Tiny Whoop FPV clone, and this is the KingKong Tiny 6, and this model, a 65mm model, is including an IO 25mm 16 channel FPV camera. I've got the deluxe edition including 5 250 mAh LiPo up to 60 C as discharge rate, and some spare props and spare top canopy to change a little bit the color design. So this box is pretty well packaged, as you can see, ideal for transportation. So let's discover this bundle. Okay, so let's discover the bundle, and this model, the Tiny 6, is also introduced in the same time than the Tiny 7. So a 75mm diagonal section, so a little bit more bigger, okay, more powerful, with some 7mm coreless motors. The review will come as soon as possible for it. So let's open this deluxe edition. So I really like the box. It's exactly the same than the KingKong 90 GT, and immediately we'll find the set of the 5 spare LiPo, some 250mm model with some discharge rate announced to be around 30 up to 60 C, okay, up to 1 watt. And let's measure a little bit the weight of it. Should be relatively light, okay, and it's ending with the micro JST PH connector with 1.25mm of pitch between two pads. So it's 6.6 grams, okay, and if you are really interested about the dimension of it, it's around about 50 by 12 by something around 6.5, and I'm wrong, yeah, 6.5. So it you will see we have a charger including in the deluxe edition. Here is a quadcopter. I will show in a few instants, but it's pretty, on the first glance I can see the plastic quality is pretty good, flexible but strong enough, so I am not afraid about the durability of the situation. Okay, so let's discover later the quadcopter itself. What we have below, we have a charger. Okay, here it's a bar, okay, where you can use, for example, with an XT60 connector, so you can use a LiPo, okay, up to from 2S up to 4S, and we have a row with the different connector. Okay, I can remove the protecting value like this, so we can recharge in the same time in parallel the 5 LiPo. We have, and 2 type of LiPo can be recharged. For the Tiny 6 here, this is the micro JST PH, and this one for the Tiny 7 with larger connectors, still some JST. And associated with, we have some tiny switch button, allow you to charge between 0.2 ampere or 0.5. It's up to you, okay. And the more important, if you don't have an XT60 battery, you can use a classic USB port. We have a micro USB port. That's great. So either if you are in the field, you can use an XT60 large capacity battery up to 4 hours, or if you have a laptop or a power bank like this, you can use in the field also such kind of power bank. It's great, really. I like this system. So what also we have bags with some free O-rings, transparent O-rings, is to attach the wire close to the motor. So if I can show you them. So we have some spare, you can see them. We have 4 spare one. We have some tiny piece of foam dampening to secure the from vibration the flight control board. That's great. And some tiny also screws to attach the top canopy. Okay, that's great. Good initiative. We have 3 bags of spare props. Okay, some white. So this 3 blade edition, orange and pink, and associated with, we have 3 spare top canopy, orange, white and pink, as expected. a prop remover branch, okay, pretty good, and the instruction manual. So if I'm not wrong, one side is English and the other side is Chinese. It's really written smallly, and we have the frequency table of the 16 channel I/O built-in video transmitter. Is divided in 4 bands. Each column corresponds a band. For example, the third one, if I'm recognizing, is the Boscan band, and if I'm not wrong, one of them should be the racer band. Okay, probably the first. But we have also the B band and so on. Okay, so I really like you have a 2-color sequence on the flight control board indicating your current selected V band. So this and each lights can take 4 different colors. So we have 2 power 4, it's equal to 16. That's great. So it's pretty easy. I like the system compared to, for example, a tiny switch, okay, a deep switch solution. What I want to say, we have 4 type of choice of receiver. Mine is the FlySky one, compatible with AFDS2A. That's great. So compatible in practice with the last FlySky radio. Be sure to have this AFDS2A protocol turned on your FlySky radio. Personally, I will bind it with my Devo 7A modded with an IF 7105 RF chip, and because thanks to the last 19 build, this ISDS2A protocol is now deviated. And we have also an option, a Tiny 6 option without any receiver. You have to install via PPM or S-Bus or I-Bus connection your favorite radio receiver. So it's really written smallly, okay, so but at least you have the list of the different frequency. So now let's focus a little bit more on the quadcopter. So here is the machine, okay, and let's give immediately the weight of this one. So standalone without the battery, we are 20.5 grams. A little bit disappointing because they were promising to be much more lighter than the real genuine Tiny Whoop, but yes, it's true, but only 1 gram, and it's because the receiver is installed, it's at least 1 gram, so we are effectively, compared to the advertised Tiny Whoop without receiver, we are 1 gram more heavy. And let's give the weight with the battery, the 250 model, and we are close to 27 grams, so it's a lot. So I hope that the motor are a little bit boosted, okay, than the standard 54,000 RPM. And let's compare with toys I recently reviewed, another Tiny Whoop clone. This is an Anhui NH010, and this one, okay, without the LiPo, was very light and 19.7 out of the box, despite this really well protecting canopy. So we are close to 1 gram more heavy for the tiny KingKong Tiny 6. But here we have, as you can see on the bottom side, a real flight control board. Is an F3 based one, so with strong processor, and it's an SP Racing. Actually, it's Betafly 3.0.1 flash, so a little bit old now. I will probably install a more recent one. We have some motor connector, okay, that's great for motor maintenance, and I strongly advise all the time to stock at least 1 clockwise and 1 counterclockwise 6mm by a 15 cordless motor. Okay, it's always good because the I will say the average mean life duration of such motor is about 20 flights, 30 flight maximum, so it's always good to stock some. But thanks to the connector, the maintenance will be very easy. We have the battery bay, okay, where would be inserted very easily the LiPo, and no problem to enter it, and to it's well installed in the battery tray, no problem. So that's good, and no intrusion of the battery in the field of view. And we have here on front 150 degrees CMOS FPV camera, announced to be 800 TVL. I don't have any information about the light sensitivity, should be around 1 lux maximum. Okay, so here is the 5.8 GHz antenna, okay, with the black insulation tube, and just here in this copper wire, as you can see, this is the 2.4 GHz antenna associated with the built-in FlySky RFHDS2R protocol receiver, so that's great. And okay, what we can find, I really like the quality of the plastic. It's brilliant, durable, so should be okay to absorb most of the crash. Let's check the solidity, the durability of the duct system. Sounds good. And the 3-blade, as I said previously, the 3-blade props should offer more flying time without losing too much motor thrust. Okay, so it's a good compromise between life, battery duration versus power lift. Okay, so now I want to show you how to bind this built-in FlySky receiver, and unfortunately we have to remove these 2 screws to access to the built-in receiver. Let's do it. Okay, so let's open the machine. So quite easy, just need to remove these 2 screws. Use always a magnetic screwdriver, it's always better. Okay, like this, and they are directly installed on O-rings, piece of foam to absorb the vibration. Okay, and here is the machine, so please sure to don't lose this tiny, but even if you, in this bag you have some spare one in case. So first remark, the I/O camera is just taped on top. Okay, and as you can see here, we have a plastic pad here where this camera is installed and taped on a piece of foam. Should be great to reduce jello. And as you can see, the flight controller board is installed on each individual O-ring, absorbing the vibration. Okay, we have as you can see, the flight controller board is rotated about 45 degrees, so should be indicated in beta flight. We have here the FlySky receiver. Okay, and we have to press the bind button while powering to be able to bind with your favorite transmitter. Here on the left side we have 2 on the flight controller board we have 2 press buttons. The lower one is to enter into boot mode. If the flashing procedure failed, you will have to press this button to force the flashing of a new beta flight version, whatever. And the upper one is the video frequency selection. So it's a sequence of click, okay, until you reach your chosen frequency according to this table. So the first one by default is red and red color, so it's the 5668 megahertz, if I'm not wrong. Okay, already selected to the first of the basscam band, so I've got a blue and red, so associated with the 5005, 705. It's up to you. You will choose your favorite. So I really like this way how it's the video frequency selection is done. So let's, for example, power the machine. So we have to press like this. Okay, and we have, as I said, the color of the video transmitter. As you can see, we have blue and red. Okay, so these 2 colors. These LEDs are for the status, and the current are selected flight mode, and the upper one here is associated with the receiver. Actually, since my radio is off, it's not bound, but as soon as it will be bound, this light will become solid. Okay, so that's pretty good. And as I said previously, you need at least to access to this canopy at least one time to bind to your favorite transmitter and to select your favorite V-frame. So let's do the binding. Okay, here is the binding procedure. First of all, on my radio I selected the HDS2R protocol. If you have a FlySky radio, be sure that this option is turned on. Okay, and I will use this power bank to provide the power via the USB, micro USB port to power of the built-in receiver. So if you want to use your the LiPo, you will have to keep press this button while powering, connecting the LiPo. Okay, so I prefer to use this power bank. It's much more easy for me to keep press and while powering the power bank like this. So it's like this. I've got the blue LED flashing fast, and then I will press the bind button, and now it's slow flashing. It means that it's bound. Okay, so to check that, we will disconnect everything, disconnect the radio, and now I will reconnect the power bank, for example. Okay, and I will turn on the radio, and I have a solid LEDs on the receiver. It's bound. Okay, working fine. So beware, as I will show in a few instants with the Betaflight default configuration. The arming is done with through a switch by default, if I'm not wrong, is aux2. Okay, so you have to know that. But now let's check a little bit the default Betaflight configuration. Okay, so let's start to connect the machine to the Betaflight. And first annoying little point is the position of the micro USB connector on the KingKong Tiny 6. In the bottom side, it means that if you need to level to make the calibration, it's a little bit tricky, will be a little bit tricky. It means that you will have to install, for example, on 4 cups the machine on each beneath each feet, and it's not super obvious. I would prefer to have more of the micro USB port more on the upper side of the flight controller board. Anyway, it's like this. So I will press connect, and immediately I will show the current version installed. So we have an SP Racing F3 board and Betaflight installed in the version 3.0.1. I strongly advise to jump immediately your default settings into a text file to be sure to restore in any case the situation if you did a bad job. So save these values into a text file, and if you need to restore, just copy paste and type save in the CLI's command, and you will restore your default settings. So let's check a little bit, press the setup to see. So as I said previously, since I installed the micro USB cable, the Tiny is not perfectly level, so don't press the calibrate accelerator. Let's check the ports. So the UART1 is obviously used, and the UART2 is the serial is turned on. So I'm not completely sure why, because I've got the FlySky receiver using PPM connection, so it's not maybe necessary. Anyway, we have a quad X situation, okay, and here I don't see any board alignment, so maybe this specialized F3 board integrate directly in hardware the 45 degrees, so be aware of that. You don't have finally to apply any alignment. We have brushed motor selected, and we have the minimum values of 1070. Okay, you will see, and you have motor stop, so immediately the motor will don't spin when you will harm the machine. We have the default gyro update and frequency PID loops, so set both to 4 kHz, which is not bad at all. Okay, and the VBAT is monitored, even if we don't have any reason to be able to monitor the current voltage input. Okay, and the black box option is turned on. I don't know why, but actually the CPU load is around 33%. So in my point of view, you can disable it. Okay, it's not very useful. So let's check the fail-safe. We have a drop, okay, which is a default Betaflight situation, and let's check now the PID settings. We have here, yes, it seems to be kind of the default settings of Betaflight. Yes, yes, seems to be. Yes, especially the D value. Nothing also special for the rate. We have close to 667 degrees per second for rate. It could be maybe a little bit faster if you are playing more to be fly acro, and we will see out of the box. The level strength is also fixed to 50. Okay, and we will check this optimization later. In terms of receiver, now we'll turn on the radio. So now I can see that most of my channel are correctly centered to 1500, no problem. I've got the my switch button here, which is the aux2. Allow me to on, as we will see in a few instants, and I've got also a two-way position here, aux1. So let's check the flight mode, and as you can see, it's only tuned set to angle mode, so no acro flight mode by default, and we have a switch here, as you can see, to say that is arm, so we will need here. Okay, so you have an arm which is the aux1, so as you can see, it's arm via the aux1. So I will probably flash in a few instants the new last beta flight version, so actually currently 3.1.7, but let's continue to see the other default settings. Okay, sensor, etc. So nothing special, so we can be sure to fly. Now we will try to attempt to install the last version of beta flight. Let's flash the new version of beta flight. So I will go to the firmware flasher section. We have to select the right board. Actually should be an FP Racing F3 board. So like this, is not an Evo, is not a Mini, and we will choose the last version. So actually this is 3.1.7. okay, and we will first try to attempt to flash like this, and we will see if we need to assign the correct DFU driver to this one. So we will see if we have an error here. Let's try to press flash. Okay, I've got a timeout, so I will try to repress flash, and it seems to work. Okay, it's a bit slow, but it works. It's a little bit slower than some other beta flight flashing, so it depends, I guess, from the type of flight control board, the destination of the flight control board. Anyway, it will take a couple of seconds, and then I will enter soon in the verify part. Okay, verifying should be a little bit faster because it's not just read the memory. Okay, and after it will be done correctly, so I didn't have to install some specific DFU driver, but in any case, if you have you have to, for example, install this driver fix for beta flight available in the internet. Okay, it should works fine. Okay, so programming successfully. Let's try to connect. Yes, so we will see the default version. Okay, version. So we have the 3.1.7. okay, and this one should also offer better performance in the PID looping and so on. So we have to resume all the default settings we had. So we had serial turn on for the UR2. I don't know why, but I will do the same. Okay, probably can be disabled. In configuration, we were no specific element. We were, of course, selected brushed. That's pretty important. Okay, and if you want or not to assign another stop, so I will keep like it was. The default is a PPM RX. That's great, and we will monitor the VBAT. Don't monitor the current, and I will select, for example, some 4 kilo and a 4 kilo here. So actually, with the default beta flight settings, I am to 7% of CPU usage. I will turn off the telemetry, the black box, and the transporter. Okay, let's save and reboot. We have only 20% of CPU usage, so thanks to the last beta flight version, we already have reduced the CPU usage. Okay, and let's now check a little bit the phase safe. It's dropped. Let's save and reboot. So thanks to the FHDS2A protocol, we should have a working phase safe situation. Let's have a look now to the default PID settings. In the last beta flight version, we have some slight modification. I will keep the default beta flight 3.1.7. I will reduce the level stress to 25, increase the rate a little bit, okay, to something around 800, okay, 800 like this. So, okay, like this and like this. And here I more apply a linear for the radar command, a linear values, okay, and apply to something around 33, and I need to apply here too, okay, to have a linear. As you can see, I've got a linear curve. So the yaw command is around 600 degrees, which is not bad. So let's turn on the radio, okay, and it's working fine, except that okay, so I will apply in any case a deadband of 4 for the RC and the yaw band, okay, but even if as you can see, the avatar of the quadcopter is not really moving, so I'm really well centered on 1500. Play with your radio with the subtrim command to center everything on 1500, and be sure, for example, that your value is exceeding, oh, I don't know why it's not working fine on the radio. Okay, so I have to read, for example, the scales to be sure that I'm inside 1100 to 2000, or to be more precise, between 1000 to 2000, okay, to be sure of that. And you have to adjust the scale and the subtrim to be in this range. We will play with the flight mode, so I won't use personally a switch to arm. I will arm normally with the throttle stick, okay, but I will play with the horizon, okay, and I want to see, for example, where I am in the okay, I will use the X2 to arm as a flight mode, okay, and as you can see, and I will be in acro mode plus air mode when I want to be in 6-axis stabilized angle mode. So let's check that. Okay, so I should be in this situation, and I have to turn on the X2 also here, so I'm safe. So no problem. In horizon, air mode plus acro. Okay, so I can eventually apply an anti-gravity or switch to the aux1, for example. It could be very fun to test that when I'm in acro, okay. So I can turn on and off the acro thanks to my switch. So no bother here, so some stuff like this, so no extra switch required. Let's see that, and now it's time to perform some demo flight with the default Betaflight 3.1.7 settings, and maybe I will need some adjustment, but I don't think so. Okay, so let's go for demo flight.